Hey, have you ever gone scuba diving? Yeah, me either. But in case you have, this lesson might just be about you. We are going to do lesson 9, session 4, 9-4. This is starting on page 215 in your book. 215. And this is really just a continuation of lesson 9-3 where we were graphing linear equations. The only difference here is they might not always be in the form of slope-intercept, which, as we know, is y equals mx plus b. So we might have to do something to be able to graph it if it's not starting in that form. So let's look at the problem of the day. Let's read this through right here on page 215. It says a scuba diver dives to 180 feet below sea level. The linear equation negative 160x plus 2y equals negative 360 represents his trip back to the surface. The variable y is his elevation in feet relative to sea level after x number of minutes. Graph the equation. Now maybe you're saying to yourself, I don't know how to graph this because we haven't learned this. That's true. We have only learned slope-intercept form where it's y equals mx plus b, and the b tells us where we can start, and the m tells us the directions to go from there using rise over run. But this equation, negative 60x, so we have the number by the x, plus 2y equals negative 360 isn't anything close to looking like that form. And we can't just say, well, there's a number in front of the x. Again, this only works if it's in the form y equals slope times x plus the y-intercept. So y equals mx plus b. So what can we do? Well, let's try to get it in slope-intercept form. Let's try to get it so that y equals something. Let's try to get it so that the right side is mx plus b. And what we have to use for this is our magic, not really magic, but our skills in solving equations. We need to get it so that y equals something. We need to solve it for y, is essentially what we're doing. So let's take this equation. Let's try to get y by itself. So what do we have to get rid of? Well, let's start with a variable. It's 2 times y plus negative 60x. We need to get rid of what is ever added to that. So we need to get rid of this negative 60x by doing plus 60x. That will get rid of this on this side. And then I need a plus 60x over on the other side of the equal sign. And you might be thinking, I can't add something with an x to something without an x. And that's right. So I'm going to bring down the 2y. And if I have negative 360 plus 60x, it's the same thing as putting the 60x in front. And I'm just thinking a step ahead because the mx part goes in front. So 60x and then plus negative 360, or just minus 360 would work as well. So now it almost looks like it's in slope-intercept form. The only problem is we've got this little 2 in front of the y. What can we do with this 2? Well, let's get rid of it. How would we get rid of a number in front of a variable? We would divide by that number. So divide this by 2. What I have to do to the other side is divide the whole side by 2, which means I have to divide both parts by 2. So now y is by itself. If I do 60 divided by 2, that's right here, that's going to get me 30. So that's 30x. And then if I do plus negative 360 divided by 2, maybe you need a calculator, maybe you don't, but negative 360 divided by 2 is negative 180. And there's an equation in slope-intercept form where we can graph it. We have the slope is 30, or 30 over 1. We have the y-intercept is negative 180, so that's where we're going to start. That must mean he's 180 feet below sea level. I think it's feet. And he's going up at 30 feet per minute. So when I'm graphing this, I'm going to make my x and y axis. It is negative 180, so I do need to have like I'm going to put it way up here. And I'm going to make these go by 30s, let's just say, because I have the slope is 30. So if I make this by -30, -60, -90, and so on, -120, -150, -180, -200. So let's just say that's my graph, and on the x's, or where it's minutes, I'm just gonna go by ones because it's every 1 minute. 1, 2, 3, 4, 5, and so on. So if I'm going to graph this, I'm going to start at my y-intercept. That's the -180. So way down here. And I'm going to use my rise of a run up 30 and over 1. So up 30 and over 1 would get me right here because I have it going up by 30. So it's nice and easy going up 30 and over 1 every single time. I can keep going to see once we get to sea level. It would take 6 minutes, it looks like. And that's the equation of my line. Or that's the line that I get from that equation. So yeah, looking at it to start, it's not in the right form. It might seem daunting. But it'll usually take us 2 steps to get it in the right form, and then we can graph. So let's do at least 1 or 2 examples to add to this. If you turn the page, what we just did there at the top, at the first model, it is the same thing. And they actually made the graph the same way that I did. So that kind of shows your rise and your run then. We're going to jump to... I do want to just mention number 1 here on the next page, where it says, how does writing the equation in slope-intercept form help you graph it? Well, we know slope-intercept form. We know the slope, what to do with the slope and the y-intercept, so that's why it's so easy. So let's do it. Turn the page, go to number 6. It's the equation -150x plus 3y minus 300 equals 0. Show your work. I'd like you to try it. Pause it and try it on your own, just to see if you can get it on your own, because you're going to have to do some of these on your own in just a second. Now, hopefully you tried it. What I would do first is I want to get ultimately we want y equals mx plus b. So we want y by itself. And right now, there's a whole bunch of stuff, by the way. So I'm going to get rid of this. Well, you can get either way. I'm going to get rid of the x for sure. Let's add 150x. And I'm going to add this all the way over to the 0, because that's the other side of the equal sign. Our train tracks here are a divider, if that helps. So then cancels out the x's over here. We're left with 3y minus 300 equals 150x, because that's just 0 plus that. Now I want to get rid of the minus 300 because I want the y by itself. So I'm going to add 300 here. And I'm going to add 300 on this side. Now remember, you can't add it to the 150 because they're not like terms. So it's just 150x plus 300. We leave it in that form. Those two can't combine. And there's one more step I need to do to get the y by itself, and that would be dividing by 3. So y is all by itself, and I have to divide everything on this side by 3. So if I divide 150 by 3, and then 300 by 3, they both need to be divided by 3. 150 divided by 3 is 50, and 300 divided by 3 is 100. So there's my equation in slope-intercept form, which is great because now I know I can start at the 100, and my slope is 50 over 1. It's given 50, so it's over 1. So if I make my graph, it doesn't have to be anything too spectacular here, but I need the y-intercept of 100. So I could go up by 50s, I could go by 10s. I'm just going to go up by 50s. 50, 100, 150, 200, and so on. And on this side, I'm going to go up by 1s because I can. Now, how you pick, again, thinking about the y-intercept is 100. I would want that, I have to be able to get the y-intercept of 100 on there. And if I'm going up by 50, up 50 over 1, that's why I have the x's going up by 1s, because I don't need them to go up by anything bigger. Otherwise, it's not going to show very good on the graph. Up 15 over 1, get me right here. Up 15 over 1, we'll keep going like that, and my line will look like this. All right, let's do one more like that. I'd like you to try number 8. Go ahead and try number 8 on your own. It's 20y. Well, you can read through. It says the marine biologist is using the underwater drone to study a delicate coral reef. The linear equation 20y minus 30x equals 900. Oops, 20y minus 30x equals negative 900 gives the drone's elevation in meters from the surface after x seconds. So graph the equation. We need to find the slope and the y-intercept, so we have to write it in slope-intercept form first. So give it a try, and then I'll show you how to do it if you're stuck. All right, when I solve it for y, I ultimately get y equals 3 over 2x equals, minus 45, which could be interesting how you graph it, because we need to start at negative 45 and go up 3 and over 2 every time. So I'll leave that to you how you want to number it. But it does ask what is the slope? So that's 3 over 2. And what is the y-intercept? That is negative 45. And what is the part of the graph represent in this situation? Or what part of the graph represents this situation? So if we're just looking at the two parts here to help us understand it, the negative 45 must be the elevation. So how many meters below surface it is, and the drone is, and this is how much it's the drone rising in the water. And that's what I'm going to leave you with. Instead of graphing that, I'm going to let you graph that on your own. This is section 9.4. It's taking what we know about solving equations and combining it so that we can graph equations that aren't necessarily written in slope-intercept form to start. So that's lesson 9.4. Have a great rest of your day.